Hello children, we will continue the whole number chapter. In today's session, we will start up with second part of whole numbers. Before getting into the session, I request all of you to be ready with your notebook and stationery items. Students, before starting up with the topics of second session, so we will recapitulate the topics what we have already discussed from first session. So, in the first session we have learnt about natural numbers, successors and predecessors, whole numbers, number line, performing addition, subtraction and multiplication on number line. In this session we will learn about properties of whole numbers, that is closure property, commutative property, associative property and distributive property, and also identity, that is additive identity and multiplicative identity, and pattern in whole numbers. These are the topics we will study in detail in this particular session. While coming to the properties of whole numbers, we need to learn closure property, commutative property, associative property and also distributive property. First, let us go for closure property. Closure property of addition, closure property of multiplication. Children, to study about this closure property, will move to an activity. Come, let us move to learn closure property of addition and closure property of multiplication.
Students, let us perform an activity of closure property under addition. For this, we use number line which contains whole numbers from 0 to 30. Students, let us add two whole numbers 3 and 4. Let us add two whole numbers 3 and 4. 3 is present in this number line, so that I can say 3 is a whole number, and 4 is also present in this number line. You can also say that 4 is also whole number. The sum of these two numbers 3 plus 4 is equal to 7. Students, you can also see that 7 is present in this number line. Is it correct? By this, we can state that on adding any two whole numbers, the sum is still a whole number. Students, now we will perform an activity of closure property under multiplication. From this number line itself, we will perform an activity. Students, let us multiply two whole numbers, that is 2 multiplication symbol into 5. So you can observe that 2 is a whole number which is present in the number line. 5 is also a whole number which is present in the number line. Is it correct, children? Now, the product is 10. Is it correct? 2 into 5 is equal to 10. So, 10 is a number which is also present in number line. So, 10 is also whole number. Is it correct, children? So, by this we can state that on multiplying any two numbers, the product is still a whole number. I hope you have understood the closure property under multiplication, children. Thank you.
I hope you have enjoyed, children. Activity was very clear. So, let us move to the further aspect of closure property now. Closure property of addition. So, what this closure property says, according to the activity we have learnt, and the same thing, on adding any two whole numbers, the sum is still a whole number. This is what we have studied through an activity. Is it correct, children? Yes, that specifies that here 3 and 5 are whole numbers, the sum 8 is also whole number. 7 plus 3 is equal to 10, here 7 and 3 are also whole numbers, 10 is also whole number. Is it correct? Hence, we can conclude that closure property is closed under addition. Is it correct? And we can also say that A plus B is equal to C. Okay. Closure property on addition, that is A plus B is equal to C. Here A and B are whole numbers and the sum C is also whole number. Closure property of multiplication. Even this we have learnt with an activity. So, which says on multiplying any two whole numbers, the product is still a whole number. Yes, of course. With the help of activity we have learned, no children, the same thing we are explaining here. That is 3 into 5 is equal to 15, 3 and 5 are whole numbers, 15 is also whole number. 7 into 3 is equal to 21, 7 and 3 are whole numbers and also 21 is a whole number. Is it correct, children? We can say that closure property is closed under multiplication. Hence, we can also say that A into B is equal to C, where A and B are whole numbers. The product C is also a whole number. Understood, children? Let us move to closure property of subtraction and division. So, we have set of examples here. So, with the help of this, we will try to see closure property whether it will holds good for subtraction and division. So, first thing, 6 minus 2 is equal to, yes, of course, 6 minus 2 is equal to 4, 4 is a whole number. What about 7 minus 8? 7 minus 8 is equal to, yes, we cannot subtract this, children. Is it correct? Hence, we can say that it is not a whole number. Next, 8 divided by 4, which gives you 2. And you can say that 2 is a whole number? Yes. Next, 5 divided by 7. Division is not possible, hence it is not a whole number. Can you try this? 6 divided by 5? Yes. 6 divided by 5 is also not possible, children. Hence, even it is not a whole number. By this, I can say that closure property is not closed under subtraction and division. Next, we will move to commutative property. We will see commutative property of addition first. What it says? For example, we have 3 apples over here and 2 oranges, which gives you 3 plus 2 is equal to 5. Is it correct, children? And in another side, 2 apples and 3 oranges. So, which gives you 2 plus 3 is equal to 5. See, children, you can observe here 3 plus 2 is equal to 5 and 2 plus 3 is also equal to 5. I can conclude that if two whole numbers are added in any order, the sum will not change. Is it correct? Yes. See here, 3 plus 2, 2 plus 3, which gives you the same sum. Hence, I can also write the commutative property of addition in this manner, that is A plus B is equal to B plus A. That is nothing but you can add two whole numbers in any order. I hope you have understood. Next, we will move to commutative property of multiplication. Children, see here, here we have number of oranges. The oranges are arranged in 4 rows and in 3 columns. 4 into 3 is equal to 12. Next, here we have set of apples and they are arranged in such a way that 3 rows with 4 columns, that is 3 into 4 is equal to 12. If two whole numbers are multiplied in any order, the product will not change. Is it correct, children? Here 4 into 3 is equal to 12. 3 into 4 is also is equal to 12. Hence, I can say that A into B is equal to B into A, which means you can multiply two whole numbers in any order. Next, we will come to commutative property of subtraction. Here we have 4 oranges, in that 3 I will subtract, so the answer will be 1. And here we have 3 oranges, out of this 4 cannot be subtracted. Is it correct, children? So, by this I can say that A minus B is not equal to B minus A. And also I can state that commutative property is not closed under subtraction. In the same way, we will go to commutative property of division. Here we have an example, that is 6 divided by 3 is, what is the answer, children? It is 2. What about 3 divided by 6? Of course, it is not possible to divide. Hence, I can say that A divided by B is not equal to B divided by A. By this, I can also conclude that commutative property is not closed under division. Come to associative property. We will learn this associative property of addition with an activity. Activity question says that Ramesh planted 9 trees, Suresh planted 7 trees, Asha planted 3 trees. Can you tell how many trees were planted by 3 of them together? So, Ramesh planted 9 trees, Suresh planted 7 trees, Asha planted 3 trees. We have to find the number of trees planted by 3 together, 9, 7 and 3. If we need to find the sum, that is 9 plus 7 plus 3, we can able to find the answer, but according to associative property, we will rearrange the numbers in two different manner, that is 9 plus 7 plus 3. Here first two numbers we will group and we will try to find the solution. So, 9 plus 7 will gives you 16, with plus 3 the solution as 19. And in another way, 9 plus 7 plus 3, here last two numbers we will group and we will try to find the solution, that is 9 plus 7 plus 3 is nothing but 10, which will gives you 19. See, we can associate them and we can able to find the solution. So, hence here we can say that whole numbers are associated under addition. We will learn associative property of multiplication. See children, here we have set of tomatoes. In each set we have 3 rows and 2 columns, correct now? Like that we have 4 sets. Total number of tomatoes are nothing but we can take in this manner, that is 2 columns into 3 rows into 4 sets, which can also represent in this manner to find the product, that is 2 into 3 into 4. First two numbers we will group, which will gives you 6 into 4, that is nothing but 24. In another way, 2 into 3 into 4, last two numbers we will group here, so that we will get 2 into 3 into 4 is 12, the answer is 24. Is it correct children? Hence, I can conclude that whole numbers are associated under multiplication. Next, we will move to associative property of subtraction. Here we have the numbers 5, minus 3 and minus 1, and first two numbers will be grouped, that is 5 minus 3, answer is 2, and minus 1, the final answer will be 1. In another side, 5 minus 3 minus 1, we will group the last two numbers 5 minus 2 and the final answer will be 3. See children, you can notice that from one block we have got the answer as 1 and from the other block we have got the answer as 3. By this, I can conclude that associative property is not closed under subtraction. Is it correct children? In the same way, we will learn associative property of division. See, we will take 3 numbers, 16 divided by 4 divided by 2. First two numbers will be grouped, 16 divided by 4 is nothing but 4, which is divided by 2, which will gives you 2. In other side, the same numbers, 16 divided by 4 divided by 2, and last two numbers will be grouped, 16, which is 4 divided by 2 is nothing but 2, 16 divided by 2 will gives you 8. Even by this you can notice that in the first form we got 2 as an answer, in the second form we just have got 8 as an answer. Even by this I can say that associative property is not closed under division. Children, next we will move to another property called distributive property. So, here we have an activity, let us move towards that.
Students, we will perform an activity of distributive property. Here we have some grids. Let us count it. Totally, we have 6 rows and 8 columns. Is it correct? So, which are green and orange colored. Here we can find the total number of grids by multiplying rows and columns. That is 6 into 8 is equal to 48. Here totally we have 48 grids of green color and orange colored. Now we will distribute the grids in different color. That is green color separate grids I will make and orange colored separate grids I will make. We have separated the green colored grids and orange colored grids. Now the number of green colored grids are of 6 rows and 6 columns, and orange colored grids are of 6 rows with 2 columns. That is, I can say like this, 6 rows into 6 columns is equal to 36 grids. For green color, 6 rows into 2 columns, that is equal to 12 grids. All together, I can write in this form, that is, the total number of grids from the beginning we can able to distribute in this way, that is 6 into rows with columns are of 6 plus 2 is equal to 6 into 6 plus 6 into 2, which is nothing but 6 into 6 plus 2 is 8, 6 into 8 is nothing but 48, that is equal to 6 6 are 36 plus 6 2s are 12, 36 plus 12 is also nothing but 48. So here LHS is equal to RHS, that is 48 is equal to 48, and 48 is also a whole number. By this I can conclude that distributive property holds good even for whole numbers.
Yes, children, I hope you have enjoyed and you have learned the activity in detail about distributive property. According to the activity, I can state that multiplying a sum by number gives the same result as multiplying each addend by the number and then adding the products together. Yes, of course, with the help of activity easily you have understood, I hope children. That says the condition A into B plus C is equal to A into B plus A into C. This is about distributive property. I hope you have understood children. See, we have discussed closure property, commutative property, associative property and also distributive property in detail. Okay. In the next slide, we will see how we can make use of all these properties while solving the problems. Got it? Let us solve some of the problems based on these properties now. In this first question, find the sum by suitable rearrangement. Question 87 plus 200 plus 13. We can rearrange the numbers and we can find the sum in easy method. So, how we can rearrange the terms? See children, 87 plus 13, I will rearrange first and third term. Why? Because my simplification will be easy. 87 plus 13 I will group, plus 200 I will add. 87 plus 13, how much? Yes, it is 100 plus 200. So, your answer is ready, that is 300. I hope it is quite easy as compared to your long process of addition. We will move to second question children. Find the product by suitable rearrangement. Question is 4 into 166 into 25. Of course, we will rearrange the numbers now. See here, 4 into 25 into 166. Of course, it is very easy. Why? Because 25 into 4 is nothing but 100 into 166, and easily you can add 2 zeros children. So, hence the answer will be 16600. Got it children? So, this is what we will be using the properties. I hope you have understood children. Here we have used different properties to solve the sums. Next we will move to another property called identity property, that is additive identity. What do you mean by additive identity? Children, we will learn additive identity with some examples. See here 7 is there, plus 0 is equal to 7 itself. Okay, 7 plus 0 is equal to 7. Next 0 plus 15 is equal to 15. Next 0 plus 26 is equal to 26. Children, here you can notice that even though if we will be adding 0 to the number, our answers are not getting changed. Is it correct? Hence, 0 is known as additive identity. The whole number 0 is called additive identity, since when it is added to any whole number, the sum is identical to the whole number itself. Next we will move to another identity, that is multiplicative identity. Let us see with some example. Here 7 into 1 is equal to 7 itself. 1 into 15 is equal to 15 itself. 1 into 100 is equal to 100 itself. By this I can say the whole number 1 is called multiplicative identity, since when it is multiplied to any whole number, the product is identical to that whole number itself. Got it, children? Multiplicative identity is 1, additive identity is 0. Next we will move to next concept, that is patterns in whole numbers. What do you mean by patterns? A pattern is a sequence of numbers or pictures. We can arrange the number in elementary shape consisting of dots. That is what in the shape of patterns. Every number can be arranged as a line. Yes, of course, except 0 and 1, that you have already know. Some numbers like 3, 6 and 10 can be arranged as a triangle. So that how we can arrange, we will see now. Some numbers like 4, 9, 16 can be arranged as a square, that also we will see now. And some numbers like 6, 8, 10 can be arranged as a rectangle. See, all the numbers are whole numbers. By using these whole numbers, we can frame the patterns in such a way of line, triangle, square and rectangles. Understood, children? By this I can say that the whole numbers can be arranged in different elementary shapes. Let us see the shapes. Patterns based on shapes. We shall try to arrange numbers in elementary shapes made up of dots. The shapes we take are a line, a rectangle, square and a triangle. Every number be arranged in one of these shape itself, no other shapes are allowed. Say, children, line. By using 3 dots, we can draw a line, and even by using 4 dots, we can draw a line. And square, by using 4 dots, we can draw a square, and even by using 9 dots, we can draw a square. By using 6 dots, we can draw the rectangle in horizontal way. By using 8 dots, we can draw the rectangle in vertical way. Got it, children? Next we will have triangle. Of course, for triangle 3 vertex or the 3 dots are needed. With the help of 3 dots, we can draw a triangle. In the second figure, by using 6 dots, we are writing a triangle. With the help of all these things, you can continue the figures by using some of the dots. Okay, how we can able to do this? So here is a table which you can try. Got it, children? It is there in your textbook. By looking into the number of dots with the shapes, you can able to complete this table. Let us move to another slide, that is pattern observation. Observe the pattern and complete it and try to understand how it works. First pattern, 1 into 8 plus 1 is equal to 9. 12 into 8 plus 2 is equal to 98. Next, 1, 2, 3 into 8 plus 3 is equal to 987. I hope you have got the next pattern, children. Yes, your answer is correct. That is 1, 2, 3, 4 into 8 plus 4 is equal to what? That you have to find it out. And the next pattern, 1, 2, 3, 4, 5 into 8 plus 5 is equal to question mark. This you have to do. It's very simple. See, children, you need not to multiply, you need not to add. Okay, by looking into the pattern itself, you can easily answer to the, well, let me see, let us go to another pattern. That is 1 into 1, 1 is equal to 1, 1. Correct. Next, 1, 1 into 1, 1 is equal to 1, 2, 1. Next, 1, 1, 1 into 1, 1 is equal to 1, 2, 2, 1. I hope you have got the pattern. So, next pattern will be 1, 1, 1, 1 into 1, 1 is equal to, you have to write the pattern. Next pattern, 1, 1, 1, 1, 1 into 1, 1 is equal to, yes, you just have to find it. Got it, children? See, patterns are also very easy. Without any calculations, we can able to find the answers. Okay. Now, just we will come to assessing part. Let us solve few questions based on what we have discussed. First question, 1000 plus 0 is equal to, yes, your answer is correct, children, because 0 is additive identity. Hence, your answer is 1000 itself. 1000 into 1 is equal to, yes, 1 is called multiplicative identity. Hence, your answer will be 1000 itself. Third question, 6 into 7 is equal to 6 into 5 plus 2. How we can able to distribute? By using distributive property, we can distribute like this. See, children, 6 into 5 plus 6 into 2. Next question, numbers 3, 6, 10, 15, 21 can be arranged in dash elementary shape. 3, 6, 10, children. 3 in the sense, obviously we can go for triangular shape. Is it correct? Yes, the answer is triangle itself. I hope you have understood, children. Then we will summarize today's discussion. So, what we have discussed mainly of properties of whole numbers, in that closure property, commutative property, associative property, distributive property, identity, in that additive identity, multiplicative identity and pattern in whole numbers. So, next we have homework question, children. Copy down fast. Next we have homework question, children. Copy down fast. First question, find the sum by suitable rearrangement. 837 plus 208 plus 363. Second question, find the product by suitable rearrangement. 4 into 166 into 25. Third question, find the value of 297 into 17 plus 297 into 3. Fourth question, find the product using suitable property 738 into 103. Fifth question, fill the gap. I will show the table, you just have to fill the gaps here, children. Got it, children? I hope you have understood the chapter thoroughly and you have enjoyed the session. Solve all the sums and update to your school teacher. Thank you.